After studying the cyclic structure of the glucose, let us have one question about this. The question is, the number of chiral carbon atoms in beta D plus glucose is R. Before solving the questions, let us see what is chiral carbon atom. Chiral carbon atom is the carbon which is attached to all totally 4 different atoms or groups. Let us see the structure of beta D glucose to find out how many chiral carbon atoms are there. You can see the structure of beta D glucose here, which is the second structure. Let us count the number of chiral carbons in it. That is carbon which is attached to 4 different groups or atoms. I am going to highlight those carbon atoms so that you can understand what these chiral carbons are. Starting with the carbon number 1, that is anomeric carbon atom. This is also chiral. The second carbon is also chiral. Third one is also chiral. Fourth and fifth, all the 5 carbon atoms present in the pyranose ring of the glucose are chiral. You can see the atoms or groups attached to all these 5 atoms are totally different from one another. That is the reason glucose, that is cyclic beta form of the glucose, it is having 5 chiral carbon atoms. Same is for cyclic alpha form. It is also having the 5 chiral carbon atoms. But if you see the open structure of the glucose, it is not having 5 chiral carbon atoms, it is having 4 chiral carbon atoms. Let us see why I am saying that. For that purpose, I am again going to draw the structure, that is open structure of D glucose. That is, the hydroxyl group is on the right hand side of the penultimate carbon atom. Okay, again follow the same method. 1, 2, 3 and 4 carbon atoms. Okay, the CHO group on the top, CH2OH at the bottom. Right, I am writing the D form, that is, this is the penultimate carbon atom on which hydroxyl group is on the right hand side. Rest of the hydroxyl group like this. Okay, now write down the hydrogen and hydroxyl group, the remaining hydrogen and hydroxyl group like this. Now you can see in this case the CHO group is free, which is not a chiral carbon atom, right? In case of the cyclic structure, the CHO group was involved in the cyclization, pyranose ring formation, due to which it became a chiral carbon atom. That is the reason in case of glucose open structure, there are only 1, 2, 3 and 4 chiral carbon atoms. So while solving this question of chiral carbons, you have to see whether it is the open structure or cyclic structure. Alpha and beta forms are the cyclic structures. That is why the answer of this question is A.